So let's start. Today we're going to start with our morning work. We're going to do 16 through 20, and then we're going to learn how to move within a graph. So let's get started. So when we have model and solve, 3 wholes divided by 1/3. So I'm taking 3 whole pies and I'm splitting it into 1/3. All right, there's 2 ways we're going to do this. One, we're going to model it, and then the other way, I'm going to show you how to solve it. Okay? So easy peasy. I'm going to take these 3 and I'm literally going to cut them into 1/3. So that's 1, that's 2 that has been cut into 1/3. That is 3 that has been cut into 1/3. And then I literally count the pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So the other way to do this is when you take a whole number and you are dividing by a fraction, you're going to flip it. Remember I told you guys the other day that when you're going to flip it, so I'm going to turn my paper just a little bit so I can write in this spot. 3 wholes is equivalent to 3/1. Yes? Yes, because we had 3 whole pies. When you're doing division, you flip it and you multiply. So I'm going to flip this over. My denominator now becomes my numerator. My numerator now becomes my denominator.
That hurts me.
I know, it hurts your head. It'll be all right. So now we do exactly what we would do when we multiplied fractions. We would say 3 times 3 is 9, and 1 times 1 is 1. So we should get our 9 pieces. That's how that works.
We have a lot of.
All right. Let's move on to number 17. Number 17 says, Isaac finished 6 of the 10 homework problems. Phil has finished 2/5 of the homework. How many more problems did Isaac finish? What kind of problem is this? How many more? What kind of problem is this? Subtraction. We're subtracting fractions. So let's go back to the beginning. It says Isaac finished 6 of the 10 homework problems. So that looks like this. 6 of the 10. And Phil has finished 2/5. And you just told me that this how many more means I am subtracting. So my dilemma comes across when I say, can I subtract with different denominators? No, I have to change one of my denominators so that they are equal, they're the same. Can I count by 10s to get to 5? No. Can I count by 5s to get to 10? Yes. Okay, so I'm going to erase my equal sign so that I can make an equivalent fraction here. And I know I want to go to 10. 5 times what is 10? 2. So I'm going to write my times 2 on the bottom for my denominator, and I'm going to write times 2 on my numerator. Okay? What's 2 times 2?
4.
4. Now I have 6/10 and 4/10. Will that work?
Yeah.
All right, then I'm going to get rid of this part so that I don't get confused. Because let's be honest, we would get confused. All right, now I'm going to put my equal sign again. Now can I do 6/10 and 4/10? Yes, my denominator is going to stay tenths. All right, here's a hard one. What is 6 minus 4? 2. So how many more problems did Isaac finish? 2. He has finished 2 more of the problems. All right. Let's go to that evaluate the expression. This is a lot like number 1, where we had to do parentheses. We're not going to do exponents, your multiplication and your division, and your addition and your subtraction. And that is the order in which you have to do it in. So you always start with parentheses, then you do your exponents, then you do your multiplication and division, and then you do your addition and subtraction. So in this problem, in parentheses is 9 minus 4. I have to solve that first. It doesn't matter that there's a subtraction symbol inside of the parentheses. That's irrelevant. It makes no difference. You have to solve your parentheses first. So by doing that, I say 9 minus 4 is 5. So I rewrite my equation because I solve this first. Now it's easy. 7 times 5 is 35. And I'm done. I'm done. All right. Next one. Model and solve the problem. 2 wholes and 2/3. That is a mixed number. And I want to take it back to that improper fraction. Okay? So I'm going to fill in 2 whole bars because that says 2 wholes. So I'm going to fill in this one. And I'm going to fill in this one. Because that gives me 1 whole, 2 wholes. And then I'm going to fill in this 2/3. So 1 piece, 2 pieces, and I have filled in 2/3. So now to find my answer, I just count my pieces. 1, 2, 3, 4, 5, 6, 7, 8. So my numerator is 8, and my denominator is still 3 because each of these wholes are cut into 3 pieces. You guys probably remembered that one from last year. All right, last one, number 20. Number 20 is very similar to number 15. It's number 15, the one above. The difference is this time it's flipped. You're going to get smaller when you divide by a whole number, obviously, because if you take a whole batch of candy and you divide it by your people, you're getting less. But you're going to get bigger if you divide by a fraction. Okay, so here we go. 347 divided by 10. So I am moving back a place. How many 10s are in 347? There are 34.7. You are moving back a place. All right? So as I said, it's going backwards. It's the exact opposite of multiplication. So how many zeros on 100? 2. So I'm going to move back 2 places. So I'm going to go 1, 2, and I'm going to put my decimal right there. All right. And the last one has 3 zeros, so I'm going to put my 3, 4, 7. And I'm going to go, whoever's drawing on the screen, please erase it because that's rude. 1, 2, 3, and my decimal would go right in front of the 3. Okay. That's why it becomes decimal 347.
I was like, why are you good? But like it won't be a whole number.
No, you're going to have 33 is 1/3, so you'd have a little bit more than 1/3 of whatever it was. All right? So then this is going to be the exact opposite. It's going to be like when we multiplied up here by the 10. So what you're doing is you're saying 3, 4, 7, but you're moving the decimal 1 place back, so you're adding 1 0. And I promise we'll get into this later. This one has 2 places after it. So you go 3, 4, 7, and 2 zeros. You put your, because your decimal is here on 347, it's at the end. And so you go 1, 2 back. And I'm sorry, your guys' screens are freezing. It's probably the internet here because it's kind of jumpy today. But don't forget, everything will be on I'll put the video onto YouTube so you guys will be able to see it on Canvas. So the last one is 347. And I'm going to go 1, 2, 3. So I'm going to go 1, 2, 3. So I'm adding 3 zeros because I'm moving that backwards 3.
Why are they so obsessive? The number 343.
That's just today. This is this week's number. Next week's number will be 207, 207. So when they pick a number to do your times 10, times tenths, they'll use that number again in the division. So the number will be the same. So you can see the correlation on how they're opposite. All right. Today we're going to get into our notebook. Grab your math notebook.
Are we done with this?
Raise your hand if you're gonna eat lunch today. Raise your hand, please. Thank you.
All right, so let's get started. Today is August 27th. And today, we're simply going to do I can move within a graph. So we're going to talk about how you move from one place to another when you're doing your graph. That's all we're going to do today is I can move within a graph. All right, so here we go. Obviously, the first thing we have to have is a graph. Here's the dilemma with our graph today. Normally when we draw our graphs, we don't draw them very big because we are just literally plotting our intersection points and we're looking for the trend. Today, we're going to draw our graph larger so that we can look at being able to move within our graph. So you're going to want a little bit more space. And what I mean by that is I'm still going to go down 6. So 1, 2, 3, 4, 5, 6. Actually, that's a lie. I'm going to go down 7. But I'm going to extend it out a bit farther on my x-axis because I want to make sure that my intersection points are big enough that when I travel between, I can see the difference between the where I'm traveling. All right, so we're going to start again at 0 here, and I'm going to write origin because we know that our origin point always starts at 0. And we're going to go up 1, 2, 3, 4, 5, 6, 7. But when I go across on my x-axis, I want to space them out a little bit. So 1, 2, 3, 4, 5, and then 6. So see how I space that out more? Because when I'm moving today, I want to be able to see the difference. All right, so let's put 4 points on our graph today. So I'm going to say I want to plot a star. I want to plot a heart. Do the best you can. I want to draw a smiley face, which is really bad. Looks like his mouth goes into his eye, but whatever, it's fine. And then I want to do a square. Okay, so that's how I'm going to graph today. I'm going to graph a star, a heart, a smiley face, and a square. And then we're going to move within those. So let's put our star at 2, 2. Make sure you put your parentheses. So I am going to start at origin. I'm going to move over 2, and I'm going to move up 2. And I'm going to put my point of intersection, but then I'm going to put a star there because that is where my star is located. My star is located at 2, 2, because my x is 2 and my y is 2. All right? I'm going to put my heart at parentheses 5, 7. Close my parentheses. And I'm going to start at origin, and again, I'm going to move over to 5. So 1, 2, 3, 4, 5. And I'm going to turn, because there's a comma, and I'm going to go up. 1, 2, 3, 4, 5, 6, 7. And I'm going to put my intersection point, and I'm going to draw my heart. So I know where my heart is. Okay? My smiley face, I am going to put at 0,6. So I am going to start at origin and I'm going to move over 0. So that means I'm not moving at all. I'm just going up. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to put my intersection point and I'm going to draw my smiley face, and hopefully this time my eyes and my mouth do not connect. And then the last one I'm going to do is my square, and I'm going to put it at 6,4 and close my parentheses. So I'm going to start at origin and I'm going to go 1, 2, 3, 4, 5, 6. There's a comma, so I'm going to change directions and I'm going to go up 4. 1, 2, 3, 4, and I'm going to put my intersection point, and that is where I'm going to put my square. So I'm going to give you just a second to get that drawn.
Wait a minute. Wait, what?
No, we're not connecting them.
Hold up. I messed this all up. I was just about to say it looked like a rectangle.
It kind of does look like a rectangle, more like a parallelogram because they're going to lean.
Mine came out really bad.
It's okay. It's all right if it's not perfect.
No, I didn't put the numbers on the lines, and I had to put them in the.
It's all right. We're not connecting them. So today, what we're going to do is we're going to move within our graph.
Wait,
No. Shh.
where's the heart all the way up?
We're going to move within our graph, and we're going to show how many spots over, and then how many spots up or down that I have to go from one shape to the next.
She said write my name down on a piece of paper. Miss Haber, what happened sausage biscuits?
All right. So the first one I want to go to is I want to move from, let's say, the star to the heart. So I'm going to write move from the star to the heart. And what would I have to do, and I'm going to move this up just a little bit so you guys can see it. What would I have to do to go from the star to the heart? So here's how this is going to work. You're going to put your pencil at your star. So your pencil starts at your star. Okay? And you're going to move up to your heart. So you're going to start here and you're going to move over. And remember, your heart is at 5. So you're going to go 1, 2, 3. So you're saying that I'm moving to the right 3 and then a comma because I have to change directions and I have to go up. So if I'm right here, I'm going to go 1, 2, 3, 4, 5 up. So I'm going to go up 5. And that's how you move from one to the other. So let's try a different one. Let's try moving from, let's see. Let's go from your star. Let's go to the star again, and let's go to the square. So I'm going to erase my jumps from the first one.
I got you. Miss Haber, Miss Fendale from Tech wants to talk to you. She said she can't come in.
Give me 1 second. All right, so let's try this. So we're going to go over because we're at the star, and that's where we put our pencil. And we're going to go 1, 2, 3, 4 over. So we go to the right 4. And we're going to put our comma because we're going to change and go up. And we are going to go up to the square. So 1, 2 to the square. So I'm going up 2.